Thank you for joining us for our third community stream for the Bytecode Alliance. Today is March 28th. It's the last Tuesday of the month. Today we're doing it at 8 a.m. Pacific time. Next month we'll switch back to, I believe it's 6 p.m. Pacific time. Today we're going to get a project update from WAMR, the WASM Micro Runtime. I have the developer here with me that works on Winch for WASM time, and I'll give a brief update on some of the goings on across the Bytecode Alliance projects for the component model. If you have any questions, please hop on over to the Zulip community stream. I also included the QR code that my face is expertly blocking. Oh, nope. Well, there it is. Okay. But that's the community stream over in Zulip. All of our communication in the Bytecode Alliance happens over there. So please hop on and chat with us. So first up is the project update from Jin Wang.
Hi, I'm Xinwang. Currently, I'm working at Intel. It is my pleasure to give an update on the recent progress of WebAssembly micro runtime. The major updates from March have a pre-release 1.2.0 TypeScript to WebAssembly compilation, the newly introduced blocks, and the VM core design documents. In the recent pre-release 1.2.0, there are two important features. In the last status update, my colleague Wen Yong introduced that classic interpreter supported the latest GC proposal. Now the faster interpreter also have the support. The GC support to JIT and LT now is undergoing. We hope it can be basically functional by the second quarter. Great thanks to the Amazon team for driving the WASI thread proposal, as well as delivering the implementation for WAMR. It is a key feature for supporting multi-languages using threading capability in the WebAssembly. Having the WASM GC capability, we are actually able to think about more languages on WASM, like TypeScript. We have released some POC code under the experimental branch. It has attracted a lot of interest from the community. Xiaomi engineers have been already actively involved into the plan, design, and development for moving it forward. We also propose a SIG on the Bytecode lines for this initiative. If you are interested, you are welcome to join it. Just tell your name in the PR comments. After this SIG is approved, we plan to have a new repository for the source code. We have a few new blocks on WAMR for the users to have a better understanding of the options. This is also what we learned from Frank Daniels' feedback in his performance evaluation report. Let's quickly walk through the blocks and see what is talked. Okay, open the WebAssembly micro runtime repository. So go scroll down to the website, click it into the website, open the blocks. You will see all the new introduced block, like the memory model, how memory is used by the WAMR, and the globally used by the runtime, used by module lifetime, used by instance lifetime, used by execution time. Also, you can see the stacks, so how the WASM stack and the native stack grows during the WebAssembly execution, and also WebAssembly executing into native function call back to the WASM function. The heaps, WAMR support two heap types. One is the default WASI libc heaps, which is managed by the manager allocator from libc. And another type is host manager heap. This is used when there is no libc WASI libc built in with the module. So if the module need to malloc and free memory, it need to create the host manager heap, simply pass a non-zero value to parameter host manager heap during calling the wasm runtime instantiate. So in such situation, EMS is a warmer memory allocator will do all the memory allocations. The introduction to warmer running modes. Warmer supports quite a few running modes, LT, JIT, also interpreter. So it tell you how to build all the engines support different modes and using CMake variables, and also how to use the runtime API to control the running mode for single WASM instance. And finally, let's have a quick look at the new introduced VM core design document. Just click the VM core component. So we have a few documents available. So wasm function. So have all the internal data link and the introduction about the link and the execution path for the functions. Also the exports, data structure, and how it is used and how it is set up. Also globals and the stack frame format for interpreter. So hopefully use those diagrams can help developers to understand the internal design and help the future contribution to WAMR. Thank you. That is all update for WAMR.
Wow, that was awesome. Thank you, Shen. I've made a personal note that I need to go back and study your architecture diagrams because those were amazing. It looks like some of them were made from Excalidraw, which is basically my favorite tool for the same thing. Now we're going to dive into an update on Winch, which is from Saul Cabrera. And I'd like to welcome him here live with me today. Hey, Saul, how are you?
Hello, Bailey. How are you?
I'm doing great. So I think we first kind of need to introduce, well, what is Winch, and kind of give a little bit of an overview for everybody because maybe they haven't ever heard of it.
Right. Yeah, so that's a good point to start. So Winch stands for WebAssembly Intentionally Non-Optimizing Compiler and Host, which is a big word, but in the end, it means, well, it's a play on CraneLift too. So in the end, it means that this is a WebAssembly compiler specifically built for WASM time that optimizes for the opposite of what CraneLift optimizes. So CraneLift optimizes for runtime performance. Winch would optimize for startup performance. This means that it doesn't do any specific optimizations to detect patterns in your code that can be optimized. So it takes WASM and it basically lowers that to machine code, which could be x86 or ARM or any other backend that CraneLift supports. So the motivation of Winch really comes from many of the constraints that we at Shopify been having around running WASM. So we have very specific constraints, and sometimes when you are cold, you're trying to create a new module cold without any caching. That could take some time because CraneLift is going to do some work up front to optimize your code. Like for example, to detect dead code elimination. For example, like it will construct an IR from your code, and then it would say, well, this piece of code is not reachable. So let's eliminate that code and create better code for what this program is trying to do. So that takes time. Also, CraneLift has other properties like a very complex register allocation, which takes time in order for it to select the registers to be used in particular instructions. And so those two pieces together, well, were a bit challenging for us to scale in the constraints that we were thinking. So browsers have been using the technique of baseline compilation for WASM since WASM basically started. So we started thinking maybe we could apply those things into WASM time, and that's how Winch came to be. A baseline compiler, which is just a single pass, does things very quickly. It optimizes to do those things as fast as possible, so we can have that machine code ready to be executed.
So basically, from what I understand, it's going to make it so that I can initially compile and run my WASM module faster, because we've got one compilation pass that's going to be super fast, not optimized, but get it going. That is really cool. I also love the name Winch. So Winch works with some of the different idioms that are provided by CraneLift. CraneLift being the compiler used by Wasm Time. And so I know what a crane is, and I'm also familiar with a winch, right? A winch would be something that like tightens the rope or the pulley or what have you. So that's brilliant. Anytime people come up with really witty names, especially when they start with W, it means you're winning. That's really great.
Yeah.
So when did work on Winch start?
So it's something that we've been thinking since last year. So the first piece of work that I had to do there was to propose an RFC, and a shout out to Nick, Chris, and Alex from the Washington team who have been like very helpful in order for me to be able to bring this to Wasm Time. And so it started around the last quarter of last year. So coming up with the RFC, proposing it, and just having a good sense of how we would architect this. And really, like, I think that the coding pieces have been starting to ramp up earlier this year. More and more, in which we have like a more clear direction on the things that we need to do, and a clear goal on what we are targeting. And we are targeting to have core WASM at some point later this year. So this means that you will be able to configure WASM time to tell it that you want to use Winch as a compiler for a particular module, and then you will be able to have fast startup times for that particular module.
Yeah, and I think one of the first places I started reading about it was actually through the CraneLift roadmap. CraneLift puts together a roadmap, and they have since, I believe, at least 2021, but could be even earlier than that. And so for the 2023 roadmap, Winch was called out specifically as a potential way to improve performance. But I feel like over the past month, I've seen a lot of activity for Winch within the Wasm Time repo. Is that right?
Yeah, that's right. I mean, the heavy lifting was done like more slowly, if you will, because it took a lot of research and a lot of investigation how other baseline compilers were doing this. Like, for example, in the browsers, we have SpiderMonkey has a baseline compiler, V8 has a baseline compiler for WASM too. So it required a lot of research. And now that things are a bit more in place, it's a bit faster, and well, it's a bit easier to go a bit faster in terms of code contribution. So yeah, and you were mentioning that that Winch uses CraneLift internally. Yeah, that's right. It uses CraneLift's code emission pieces or infrastructure. What this means is that we don't have to do all that heavy lifting ourselves. All those pieces are hard to get right. And when I say code emission is, for example, how do I encode a move instruction in x86-64? CraneLift already has all that, and it's easily pluggable. So what we did is that we took those pieces and we are using them from Winch, basically skipping all the optimization layer that Craniff provides. So that's a huge lift for us, well, for Winch, in the sense that we don't need to go through all the very specific details that these backends have themselves. So yeah.
Yeah, it's also very exciting. I read some of the papers that were offered up in the RFC around optimization and other single pass compilers that people have made. And this one is really great and special because it's written in Rust. And you're taking advantage of some of those existing pieces in CraneLift, which is also written in Rust. So yeah, I see tons of places where it could share. I could see architecturally too that there's probably an advantage there to having a way of, right now we don't have a tiered compilation system. I believe that's correct. Yeah. So, but in the future, like a lot of other systems like V8 and others that you've mentioned, they do. And so the idea of that is, and please correct me if I'm wrong because you're the expert here, but we can basically compile one way really fast and then compile another way later, maybe even on the background or what have you, and have a more optimized version after we've already initialized. Is that about right?
Yep, yeah, that's pretty right. So one of the reasons why we decided to leave tiering of the table is because with it's a subject on its own that adds a lot of complexity. So
Mhm.
a good path would be, well, let's allow people to configure a new compiler, and then they have fast startup times with that compiler, and then we can think about tiering inside Wasm time. Maybe that's something that I've chatted with Chris and Alex slightly. So maybe we're going to get there once Winch is more complete. But what we are, in the medium term, while there is no tiering, we've been thinking that there could be a path to have some sort of manual tiering where you compile a module with Winch on the first request when you're cold, and then you swap the compilers in Wasm time, and then you generate in the background more efficient code for your next request, which means that you will be able to have that tiering. It's just that it will be a bit more manual, um, while it's not integrated in Wasm time.
Yeah, that makes a ton of sense. Wasm time, probably the top use case is being embedded, and less so maybe like the CLI front end.
Mhm.
So embedded hosts could totally take advantage of this. I'm already like eyeing it like, ooh, maybe maybe I'll start doing this soon in the projects that I work on. So awesome and amazing work. I'm gonna pull up our slide again, and just in case I forgot anything that we should mention. Oh yeah, hey, there's an easy way to run Winch. Do you want to talk about that for a sec?
Yeah, sure. So right now we're in the process of integrating Winch into Wasm time. There are a lot of details that go into there, but I think we have already a good idea, and there's a PR in the works. So hopefully after that PR, this won't be needed. But if you want to explore what Winch, uh, the code that Winch generates, you could just go into Wasm time, and then there is a directory called Winch, and then you can just run this command cargo run, and then pass in the compile and a path to a WebAssembly file, and then you pass the target. Right now, we have been trying to support AR64 too, but it's x86 is more complete. So it's probable that AR64 is just going to blow up if some of the features are not supported. But yeah, if anyone wants to try it out, that would be a good way, I think.
Cool. Are you looking for more contributors, or are there places that people might be interested in? You got any good nerd snipe tips, I guess?
Yeah, sure. I mean, there are a lot of places in which people can contribute from, instructions at the WebAssembly level that needs to be translated into machine code. So I think that's a good starting point. And I would say that there are a lot of instructions that I haven't tackled because there are, you know, there are just other things that I've been focusing on right now. But uh, that's a good place if people want to get started with this. There is a good template on how to do this. A good example on the previous instructions that I've implemented. So I would say if people want to contribute, yeah, that would be a good place. Yeah.
Cool.
Yeah, just wanted to mention that we also have like the in the meetings folder in the Bytecode Alliance. There is a meeting for Winch. So if people want to attend the meetings just to uh, listen to what we talk about in those meetings, everyone is welcome. They can just join me through Sulip and let me know. I can send an invite.
When's the next meeting?
The next meeting is actually today. Yeah, at 1:15 p.m. EST.
Okay. Is that in an hour?
Yeah, no, right now it's 11:20 EST, so in
Okay.
a couple of hours. Yeah.
Yeah, sorry, I'm so confused. I went to WASM.io, which was amazing, and you spoke at it, and that was super fun. And I'm in Ireland right now. I don't even know what time zone I'm in, so this is all very difficult. But hey, that's why we record these. That's why the Bytecode Alliance community stream rotates time, try to capture as many time zones as possible. And I will include a link to your meeting. And also the community stream also is in the Bytecode Alliance /meetings repository, and in there, basically almost all. I don't think there are others that are outside of that, but if there are, please add them to the meetings place, and that gives people simple instructions for how to join which meeting and where they're going to all be held. Cool. So this was awesome. Thank you for joining. Is there any one more thing that you wanna add before we jump off?
No, I think we have covered a lot. It's like the first time that I talk about winch. I'm going to be giving a more detailed talk in the next WASM conference, so WASM Day, I think. Yeah.
WASM Day,
So
yeah.
yeah,
WASM Day is April
18.
18th. Okay. April 18th. That's really soon, actually. Yeah, so in a very short order, that's a co-located event to the Cloud Native Kubernetes conference, CNCF. So yeah, I expect us to have a lot of more content from that, and probably by then your talk will be up from WASM.io. I also talked about components, and there were several other Bytecode Alliance adjacent talks, especially Dan Gumman. That's another one I'll give a shout out for. So yeah, there's just been a lot of content. I feel like it's accelerating right now. And Winch is pretty new to me, so I'm really glad I got a chance to learn about it from the guy who created it.
Cool. All right.
All
Thanks
right.
for having me.
Thank you. See you.
Bye.
So next up is a little bit of an update from Wasm Time. So there was a blog post that Andrew Brown put together. I think it's a really great overview of this new feature called WASI Threads. It's a proposal. It's pretty early. It doesn't work with components. So very much a technical preview, but you can try it out in 2 different runtimes. So Jin talked about it in Whammer, but it's also now available in Wasm Time. And so that was an article up on bytecodealliance.org. To enable WASI threads, you pass in WASI modules, experimental WASI threads to try it out. But there were several other changes that landed over the past month for WASM Time 7.0, including WASI sockets being added to the C API. Actually, there are a lot of things added to the C API, being able to add different types of limits to our stores. But also one other cool feature, which is WASM Time Explorer. So I feel like a lot of February was spent building a lot of different pieces for the components. And a lot of March was also iterating on top of that, but a lot of just new stuff seems to show up. So I'm going to also play a video that Nick put together, and this is his PR that he created for WASM Time Explorer. And what that essentially is a way for us to look at the instructions that are produced from a WASM module. It's a pretty short little video. It's about 23 seconds. You can't see the mouse cursor jump around, but the idea is that he can highlight over on the left and it'll show what instructions, x86 instructions, are created over here on the right. And so the high-level binary command is wasm time space explore, like this. It's the actual command to produce this. Produces an HTML file that you can open and jump around in. So I thought that was pretty cool. I wanted to highlight that one. And in case you weren't aware, I'm going to hype it again one more time, which is the new macro for working with generating components, bindings, and that's the WASM time component bindgen command. I guess one other change that landed in WASM time was it handles the case where you have a default world. So a lot of more, I guess, enhancements and ergonomics around being able to build and produce components. There is one other thing I wanted to talk about on the WASM time front, and that's that we had a security vulnerability that we fixed. There are patches now available in 6.01, 501, and 401. So if you're on those versions, please go ahead and update. One of those was a critical. And all of this follows our security disclosure policy, and that's at the bytecodealliance.org/security. And you can go to the announcement for that to see additional details. Okay, I mentioned it already, so I've kind of already spoiled it, but I wanted to give just another high-level shout out to all of the component model work that's happening across many different tools and projects across the Bytecode Alliance. There are many different producer tool chains, which like Cargo Component and WASM Compose, Wick Component. WASM Compose and Wick Component are producer tool chains that are in the WASM Tools project. Cargo Component is basically a higher level that consumes some of those that is specifically for building with Rust projects. Now, a lot of these projects already exist and have already started happening, but next up, that's the work that's underway is for resources within the component model standard. Not underway right now is working on async types. So Those are the big features for the component model. So I guess said differently, we're maybe like halfway there. But last week I was able to show with Dan Charloni, who works at Microsoft. He and I were able to do a demo where we showed multi-vendor components working together in real systems. So he had his deployed out in AKS in Azure and on a Kubernetes stack, and I had mine deployed out on a Wasm Cloud stack. And we were able to interrupt by using the WASI messaging contract. And so that was amazing. And I said contract because that's a Wasm Cloud word. I should have said interface. It's using the WASI messaging interface. So we were able to connect over NGS, which is kind of like a network, global network system for NATs, and then be able to ping and pong messages back and forth. So the demo itself was fairly simple, but all of the mechanisms that are behind it are brand new and really exciting to see combined together for the first time. And so that's basically it for our content today, a fairly short one. If you have any questions, please ask over in our community stream on Zulip. And I still have Saul here with me if anybody has any questions they want to ask. I see Liam was able to post the RFC about adding baseline compilation to WASM time. I will give it just a few more minutes just in case anybody jumps in, but no rush. That means we covered it perfectly, right? If we don't have any questions. Okay, I'm gonna call it. We're always available, we're always online, and you can ask questions over there at any time. I hope everybody has a good night, morning, evening.